Okay, so for this second part, we're going to be looking at the speed of a particle for a rock to hit the ground, or for a rock to hit the particle, the speed of the particle for the rock to hit it at 10 meters above the ground. So what we're looking at in this first case, now we're going to have to look at the rock distance function. And we're going to let it equal 10. So x for the rock is equal to minus 5t squared plus 20. So now I can substitute the 10 in. We're going to move this 20 to the other side, which will give me negative 10 is equal to negative 5t squared. Then we're going to take this negative 5 across to make it positive 2t squared. Take that squared across, and that's going to give us a positive and a negative case. So therefore, t has to be equal to root 2. Now, it's going to only be the positive because in this scenario, it doesn't make sense for us to have a negative solution. So we're going to be taking the time that the two things will collide at 10 meters, or the time that the rock reaches 10 meters is going to be root 2. So we're going to use that fact to manipulate our other function. So here's what we know about our other function. We know that our velocity is equal to negative 10t plus a constant. Now, I can substitute in that t is equal to 0 when our velocity is at its initial amount. So we're going to let that happen. So now VO is equal to negative 10 times 0 plus c, meaning that our constant is our initial velocity. So next thing we're going to do is we're going to restate the function with our velocity substituted in as c, and we're going to change this into the rate of change that it is. So it's the change in distance with respect to the change in time. So now I've got that minus 10t plus VO. Okay, so to get our displacement function for this, I'm going to integrate it with respect to t. Now I've got x is equal to minus 5t squared plus VOT. That should have been that. Okay, plus some constant. Now, the next thing that we want to do is we want to let our distance equal 10 and our time to equal negative 2. Now, the point of doing this is because that's going to tell us the position, or the only thing that's going to be left is our velocity. So we'll have the time, we have the displacement, and it will solve for the velocity. Now, I've just realised that I didn't actually solve for c, but we use our initial fact that when x is equal to 0, t is equal to 0. So that means that this times 0, this times 0, the only thing that we've got left is that c is equal to 0. So that's why that our next function works out to just be minus 5t squared plus VOT, and we lose our constant on the end. Now I'll substitute in. So 10 is equal to minus 5 times root 2 squared plus VO times root 2. I'm going to first multiply this. So the square root of 2 times the square root of 2 makes just one old positive 2. This will simplify to negative 10. When I take that across, it will become 20, which will leave me just with VO, or the initial velocity, or the velocity of our function. Probably should stop calling it the initial velocity. It is just the velocity of our function is equal to, and then we take this one across by dividing by root 2, meaning that the velocity is equal to 20 over root 2. Now, the problem with this one is that if I leave it at this point, I haven't rationalised our denominator, which is something that we don't like in math. So we're going to multiply the top and the bottom by root 2 to rationalise it, which will give me 20 root 2 over 2, which will give me 10 root 2, and that is the velocity in meters per second.